Hi everyone, it's Mrs. Martello. We're still in section 5.3. We're going to look at another type of example of solving by elimination, but now we might need to multiply both of the equations. So we're going to take a look at number 17. This is from the exercises on page 251. So my equations are 9x plus 2y equals 39 and 6x plus 13y equals negative 9. So first, they're in the same form, x, y equals a constant, which is good. Now look at your numbers. These are not the same number. These are not the same number, so I can't just add or subtract these equations together. I'm gonna have to multiply. But can I multiply 6 by a integer to make it into 9? No, it'd have to be a decimal, and I don't wanna multiply by a decimal. Can I multiply 2 by an integer to make it into 13? No, not by multiplying by an integer. I would have to multiply it by a decimal, and that makes it more complicated. So what we're going to do here is we're going to pick one of the variables and multiply to make them both become the same number. So imagine we were to work with these x's here. Let's find out what number does both 9 and 6 go into so I could make these become the same. Now, when I'm thinking about the number, I want to find the least common multiple. Find the least common multiple, the LCM, the least common multiple. Well, I know that 9 goes into 18 and 6 goes into 18, so I could make these both into an 18, and I could also try to make them opposite signs, right? Don't forget about opposite signs so that we can add. So I could make one of them positive 18 and one of them negative 18. That would be fine. Or I could do the y's. I could make them both into 26, right? Multiply this and this, make them both become 26. That would be the least common multiple. And that's totally up to you. You get to decide which one you want to choose. I think I'm gonna choose the x's. So let's go ahead and do that. I'm gonna make this first x into a positive 18 by multiplying this equation by 2. And let's multiply this second equation by a negative so that they're opposite signs. Let's make it a negative 18, so I'm gonna multiply by negative 3. Okay, let's write our two new equations here. Don't forget you're multiplying every single term. This would be 18x plus 4y equals 78. Let's multiply the second equation. This would be negative 18x minus 39y equals positive 27. Okay, I multiplied both of the equations. Look at these x's now. They have the same number and the opposite signs. So now I can add these two equations together and get these x's to eliminate. So let's add them here. This is going to be negative 35y equals, let's add these together. This would be 15, carry the 105. We're going to solve for y. Let's divide both sides by negative 35. And this would be y equals negative 3. And I just found my y. Okay, let's plug it back in and let's find our x. So I think I'm going to plug it into the first equation, the original one I was given. So 9x plus 2y equals 39, and let's plug in negative 3 for y. 9x plus 2 times negative 3 equals 39. 9x minus 6 equals 39. Let's add 6 to both sides. 9x equals 45. Divide both sides by 9, and I get x equals 5. Let's write our answer as an ordered pair. So our x is 5 and our y is negative 3. So our solution here would be 5, negative 3. Okay, for something like this, it's definitely worth your time to check your work because we did so much work in this problem. Let's take the time to check it and make sure that it actually does come out correct. Let's do our check. Okay, we're gonna do the first equation. Let's plug it in. 9 times 5 plus 2 times negative 3 equals 39. This would be 45 minus 6 equals 39. Yep, that one is correct. Let's try our second one. Let's plug in the point. 6 times 5 plus 13 times -3 equals -9. This would be 30 minus 39. Yep, that equals -9, and I know I got it correct. Okay, we're gonna take a look now at example 3. And example 3 is a nice real world problem of using systems. So when we're doing this, remember when you're writing your system from the word problem, you need to be careful and you need to make sure you're writing 2 equations. So think about how you can separate the information and write 2 equations based on what you see here. So it says a business with 2 locations buys 7 large vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? So let's first define our variables here. So why don't we say that L stands for the cost of a large van, and we'll say S is the cost of a small van. And you could use X and Y if you wanted to, but it helps me to remember which one stands for which when I use the variable that goes along with what it actually stands for. Let's separate our information. Well, I have 2 locations. They each have their own totals. Let's write an equation for each one. Our equation for location A, we have 5 large vans, so 5L, and 2 small vans, so 2S, equals a total of $235,000. Our next equation is going to be about location B. We have 2 large vans plus 3 small vans, and that's going to give us a total cost of $160,000. All right, I have my system written, and now I'm ready to solve for finding the cost of each type of van. Look at how they're in the same form. My L, S, and constants are lined up. Now let's look at the numbers. These are not the same. These are not the same. I'm gonna have to multiply. Can I turn a 2 to a 5 by multiplying by an integer? No. Can I turn a 2 to a 3 by multiplying by an integer? No. So let's decide, do I wanna make the L's become the same number, or do I wanna make the S's become the same number? And that's up to you. If I choose the L's, we would make them both 10, or I would do opposite signs, so 10 and -10. And if I did the S's, I would make them both 6 and make them opposite signs, so 6 and -6. And that's totally up to you, it doesn't matter. I think I'm gonna choose the L's. So why don't we make this into a positive 10 by multiplying the whole equation by 2. And let's make this second one into a -10. Let's multiply the whole equation by -5. All right, so I'm gonna go underneath here and I'm gonna write my new equations below it. This is gonna be 10L plus 4S equals $470,000. Let's do our new equation for B. We're gonna distribute, be careful, make sure you multiply every term. -10L minus 15S equals, if you want to use your calculator for this, that's totally fine. So 160,000 times -5 would be -800,000. Now look at our L's. We have the same number with opposite signs. We are ready to eliminate these L's by adding the 2 equations together. Let's eliminate the L's. These cancel out. We're gonna add these together. This would be -11S. Let's add these together here. Just be careful when you're adding. Plus 470,000 would be -330,000. We're gonna divide both sides by -11. Oops. And we would get S equals 30,000. And that's how much it costs for a small van, Okay, let's plug this back in and let's find our L. And doesn't matter what equation you plug it into. Let's do this second equation, the original second equation, just because the numbers are smaller. Let's plug it in here. So I'm gonna do 2L plus 3S equals 160,000. Let's plug this in for our S. 2L plus 3 times 30,000 equals 160,000. We're going to multiply these here. 2L plus 90,000 equals 160,000. Subtract 90,000 from both sides. 2L equals 70,000. And we'll divide both sides by 2. And here I get L equals $35,000 for a large van. Let's just make sure that I did that correctly here. So 160 minus 90 is 70. Yeah, so I did do that correctly. All right, that would be our answer to this question. So it would be 30,000 for a small van and 35,000 for a large van.